Hello guys! Welcome again to my YT channel. Hello world, hello Philippines, hello other parts of the world. This is again, I am a singer, eternal voice. This is my legit YT channel. Okay, so at this point in time, we will be able to discuss the very basic foundation of, chemistry or physics, physical chemistry, thermodynamics, or it's all about pure sciences, okay? But in here, it's more on chemistry, connected to physical chemistry, and then related also to physics, something like that, okay? And this deals of process. So when we mean about process, it's composed of a system, okay, and the surrounding. Okay, so what's in the process are, for example, activities, okay, or any operations, or shall we say, specifically a chemical reaction in which we are dealing here, as an example. Okay, something like that. If I have my coffee, my gosh, this one. My coffee is hot, okay, and there's a higher temperature. Okay, so after that, if I will stand this for 5 minutes to 10 minutes, okay, even if there's no external hot temperature in the surrounding, okay, or there's no external coldness of the surrounding, like that. So this hot coffee, time will come, this will become cold, okay, to its natural process. Okay, meaning at normal condition. Okay, so that would be, time will come, it will become not really that cold, normal temperature, or not hot anymore. It's totally different if your surrounding have an AC, air conditioning, and this coffee, hot coffee, will easily be cold. So now there's a relation between the process, system, surrounding, and the process. Now in here, we are concerned with how spontaneous the chemical reaction and how non-spontaneous the chemical reaction, or spontaneous process or non-spontaneous process. Okay, so in my example, okay, the spontaneity or the spontaneous process is the one, the hot coffee being let the hot coffee be cold without the AC. Okay, so it will just be cold, or it's normalized the temperature if you stand this for 5 minutes and minutes, okay, without the AC, meaning to say without uh, internal energy or any energy applied to the hotness of this hot coffee, it will become cold later on. Okay, but if there is an easy in your surrounding, it will become easily cold. Okay, like that. So there's an internal energy, or there's an energy added, which is the AC. Okay, so there's an AC, okay, that is then spontaneous, and without AC, that is spontaneous. Okay, so generally we can say that spontaneous process or spontaneous chemical reaction, it will just proceed by its own without additional external energy, or without adding energy into it. It will just proceed by its own. So that is spontaneous process, spontaneous reaction. And the reverse is non-spontaneous chemical reactions, but non-spontaneous process, meaning we need to add external energy or amount of energy in order to proceed the process, okay, like that, and the chemical reaction. Okay, that's the clear difference, the general impact of a basic understanding of spontaneous and spontaneous. Now, okay, if we try to account to the reversibility of the process and the irreversibility of the process, okay, so we can say that there will be an increase of reversibility of the process of chemical reaction. So meaning to say, that's spontaneous. It will just proceed by its own. So that is for reversible process or reversible chemical reaction. Now for a reversible chemical reaction and process, so it needs energy, so that is non-spontaneous. Okay, like that. So now we go now to explain to you. Wait, okay, a little bit. So this is gonna be, let's see, the process. This is composed of the system and the surrounding. So the process is composed of the system of the surrounding. Okay, and let's apply the quantities involved in this study of thermodynamics or physical chemistry or chemistry or physics. We have the first, we need to consider the internal energy or delta U. Okay, delta U or change in internal energy. Second, the heat content or the heat energy, which is the Q, or the change of heat content or heat energy transferred, which is the enthalpy. Okay, next we need to consider the entropy, the randomness or disorderness of the system. Entropy. Okay, the last will be the Gibbs Free Energy, that determines the spontaneity of the process or the chemical reaction. Now guys, we need to know different definitions for each quantity. Okay, delta U, change in internal energy, the heat or the enthalpy change, the entropy and enthalpy, so that we can understand what's really going on in the process that composed of the system and the surrounding. Okay, like that. So in here, what is being applied here is really the laws of thermodynamics. Okay, the zero law of thermodynamics, the first law of thermodynamics, the second law of thermodynamics, and the third law of thermodynamics. So these four laws are also discussed in chemistry, physical chemistry, and also in physics. So it depends on the delivery and the discussion or the presentation of the instructors. My point is, these are really covered, okay, in these four subjects. Okay, I don't think so in unit operations or unit processes or chemical reaction kinetics. I think it will be applied also a little bit, or the principles and concepts. But what I am telling you is usually applied to physical chemistry, thermodynamics. We have chemistry also and physics. Okay, because physics is a study of matter and energy, and these are all related to energies. Okay, and solid, liquid, gas is a states of matter. So basically originated from chemistry talaga siya. Okay? We need to understand. Okay? Now, our focus now is the difference between the spontaneous and the non-spontaneous. Okay. Now, we have here let's see, like this. Spontaneous and non-spontaneous. Okay, so class, for me, the best identification for this quantities here, or thermodynamic quantities, shall I say, is the delta G, the Gibbs free energy. Because the Gibbs free energy, or the free energy change, is really determining the spontaneity of the process. How spontaneous the process really is. And it has been described how spontaneous, how non-spontaneous the chemical reaction of the process. So I must start delta G so that I can understand the other quantities relationship, so that I can determine the chemical reaction. Okay, like that. And then I will connect that to the enthalpy and the entropy. Here, enthalpy and the entropy. Okay, since the internal energy, or the energy, is just in the general point of view that the spontaneous process or chemical reaction doesn't require energy to proceed the chemical reaction or process by its own. It's very easy, so let's forget a little bit with the internal energy. So any chemical reaction will not proceed without internal energy, so that is spontaneous reaction. So that means it's reversible chemical reaction. Okay, now the reverse will be spontaneous. Is very understandable, right? Okay, now we'll start with letter G. So if it is spontaneous class, the delta G will be negative. Oh my gosh. So if it is spontaneous class, our Gibbs free energy, or the change of free energy, is negative. So if it is negative, that is less than 0. So like that. Okay, less than 0. Now, what is the relation between Gibbs free energy and the heat now and the enthalpy? Okay, so if it is spontaneous, so if our process and chemical reaction is more spontaneous, so there will be a direct relationship with the enthalpy. So our enthalpy also will be equal to 0, or zero, not 0, equal to negative also. Sorry, since this is directly proportional with each other, not really 0. Sorry for that. I said delta G is negative or less than 0, so delta H, or enthalpy, also will be less than 0 or negative. Okay, now if it is negative delta H, so that is negative, meaning the heat is being removed from the system here. So if that is a negative heat or less than 0 enthalpy, so it is being removed from the system. So if it is being removed from the system, if the heat or the enthalpy content is being removed from the system, meaning it is being released to the environment or the surrounding. Let's just use the word surrounding. So it is being released, the heat content or the heat is being transferred to the surrounding. So if the heat is being removed from the system, take note the term from. So this is a, what do you call that one? So this is exothermic reaction or endothermic reaction. So this is an exothermic reaction. So class, if the heat is being removed from the system and we have a negative heat which is less than 0, therefore we have an exothermic reaction or exothermic process. So the heat is being removed from the system, so the heat is released to the environment or the surrounding. If the heat is released to the surrounding will become hot. Okay, like that. That is exothermic environment. For example, I'm sitting here. This is a very hot environment or very hot office. Okay, so high temperature, right? So this process is exothermic. Okay, or exothermic condition, like that. Okay, now, so I have relate the delta G and delta H relationship, right? Directly proportional with each other. Okay, now we go to the entropy. Okay, so the more it is spontaneous, okay, the entropy will increase. So the entropy will increase. So the entropy now will be greater than 0. So the more it is spontaneous process or chemical reaction, the delta S will increase, meaning to say there's more randomness and disorderness of the molecules in a microstates in that particular system, like this. Okay, we are referring to system and good shock. Okay, so that's the relationship. So in summary, in spontaneous reaction, the Gibbs free energy is negative, meaning to say less than 0. So your enthalpy is directly proportional with that. So meaning to say that your enthalpy or heat also will be less than 0 or negative. But your entropy, change in entropy, will be greater than 0, or entropy will be positive. So let's go now to the non-spontaneous. Non-spontaneous doesn't require internal energy to proceed the chemical reaction. This is increasing the irreversibility of the chemical reaction. So the delta G in non-spontaneous is positive. Oh my gosh. Okay, positive. Okay, so the delta G is positive. So meaning to say that this is greater than 0. So your enthalpy also will be greater than 0 or positive, because the delta G and the enthalpy is directly proportional with each other. Okay, your enthalpy also will increase, and a positive value of enthalpy directly proportional with each other. So inversely proportional with the entropy will decrease. It is less than 0. So our entropy now is less than 0 for the non-spontaneous reaction. So again, the same relationships. The delta G of change in free energy is directly proportional to the enthalpy, but this delta G is inversely proportional to the entropy. Okay, like that. So that's for the non-spontaneous. The reverse only for the spontaneous. Now, so how can I say that that is an endothermic reaction? We have now the exothermic, right? So it is an endothermic reaction if it will absorb the heat or consumes the heat. If the surrounding will consume and absorb the heat, meaning to say that surrounding will become, okay, if it is absorbed and consumed, so there will be no more heat anymore because it's being consumed. So it will become cold. The environment will become cold, or the surrounding will become cold. So that is endothermic reaction. Okay, endothermic reaction. Okay, so meaning to say the heat is being released to the system also. Okay, so if the heat is being released to the system here, so the heat is being added now to the system here. Okay, if the heat is being added to the system like that, so if we take into account the reference as the system, so that is endothermic reaction or endothermic process. So let's go back now. So exothermic reaction, releasing the heat to the surrounding. So this is an endothermic. If we refer the system, so this is a negative heat. Now, for a positive heat, meaning to say, okay, this one, the heat from the surrounding is added to the system. So if it is heat added to the system, that is, okay, endothermic here. So meaning to say, even if our reference is a system, there's also an endothermic here, and there's also an exothermic here. The exothermic here is the heat is being released to the surrounding. And the endothermic here is that the heat is being added to the system. Okay, now here, the endothermic here is the heat is being absorbed and consumed by the surrounding from the system. So this is our endothermic. So meaning to say, if it is consumed, the surrounding is very cold. Now, the heat is being released to the system. So that is exothermic, basing the surrounding. So in the surrounding also reference, we have also the exothermic and we have also the endothermic. It depends on the, the phrasing of the sentence. If I will say, the heat is being released from the surrounding, okay, so this is an exothermic reaction in the basis of the surrounding. Okay, if the heat is being added, okay, to the surrounding from the system, so this is an exothermic reaction like that. Okay, because it is being added, the heat added, so the more the surrounding become hot. Okay, so the more it become hot, so exothermic reaction, meaning it receives the hot of this like that system. It's gonna be like that. You should understand also with which is an endothermic reaction and which is exothermic reaction. That's why, to make it more understandable, we need to refer the surrounding as our reference in telling an exothermic or endothermic reaction, because it's easy. For example, that is a very hot environment or surrounding, that is exothermic. Okay, because the system is releasing heat to the surrounding. Okay, if the environment is very cold, that is endothermic. Okay, like that, because the surrounding is absorbing and consuming the heat from the system. Just only think of that. Okay, so if the heat is being released from the system, so it is also being removed from the system. So the reverse, if the system will really absorb the heat or consume the heat, so that is really an endothermic reaction referring the system. The terms, you should be careful with the terms. So if we say pala heat absorb, okay, like that, and heat release, that referring to the system. Okay, in physical chemistry and thermodynamics. But in chemistry, it's more on talking about the surrounding. That's why the signs are changing, or the reverse will hold true, because our reference in physical chemistry and thermodynamics are more on the system, and in the chemistry more on the surrounding, something like that. So that's why it will change. How can we say exothermic? How can we say endothermic, like that? Okay? And how can we say spontaneous, and how can we say non-spontaneous? Okay, I hope this video will give you a guide to differentiate between a spontaneous process or spontaneous chemical reaction, between spontaneous or non-spontaneous chemical reaction and non-spontaneous chemical reaction, the reversible chemical reaction, the irreversible chemical reaction, the reversible process, and the reversible process. So this video also presentation will help to identify and correlate the relationships between internal energy, the heat or enthalpy, entropy, and the Gibbs free energy. So through that we can determine how spontaneous the process is, how spontaneous the chemical reaction is. Okay, something like that. Okay, thank you so much for watching this video. Then you can comment down below in the comment section if you like. And then if you are not subscribing yet my YT channel, then you can subscribe now if you want also. And you can click for more videos and more updates of I Am a Singer, Eternal Voice. Bye bye, God bless everybody. So ang enthalpy jud ang delta G mo directly proportional. Delta H and enthalpy directly proportional. Pero ang imong enthalpy mo dili is G. Okay, ganun.